Hello students, today we will discuss about the new group that is called the group 17, and the general configuration of group 17 is NH2 and P5, and the first member of group 17 is fluorine, chlorine, bromine, iodine and astatine. It is known as commonly halogen family. Halogen family. Halogen means halo means salt, gene means producer, means salt producer family. The first member of group 17 family is fluorine, that is it is also known as fluorine family. So let's at first we discuss about their electronic configuration. So students, here we will use the inert gas configuration. At first helium, then 2s2, 2p5, and atomic number of fluorine is 9, chlorine is 17 and bromine is 35, iodine is 53 and astatine is 85. So write down the configuration. Inert gas configuration: neon and 3s2, 3p5, bromine, argon 3d10, 4s2 and 4p5. Iodine, inert gas we use krypton 4d10, 5s2 and 5p5. Now for astatine use xenon 4f14, 5d10 and 6s2 and 6p5. So this is their general configuration. Here we see that all the electrons come in the p orbitals and their valence electron is 7, 5 and 2, 5 and 2, 5 and 2. So S and P are involved in the configuration of group 17. Let's we discuss about their general configuration or characteristic of this group. So at first we discuss about the atomic radius, atomic and ionic radii. So students, atomic and ionic radius increases as we moving down the group. The atomic radius or ionic radius are increases. The radius of an ion is always greater than its neutral atom. The radius of cation is always smaller than the neutral atom. So the radius decreases in the order. So at first we will talk about the periods and the group. As we know, when we move top to bottom, the size of atom increases. And when we move left to right in a period, the size of atom decreases. And we also discuss about their ionic form, and the ions of anions are always greater than the size of neutral atom, means iodide ion is greater than iodine. Similarly, chloride ion is greater than neutral atom chlorine. So here we discuss the atomic or ionic radius general characteristic. What happened when we move top to bottom? The size of atom increases. When we move left to right in a period, the size of atom decreases. Let's we discuss about the ionization enthalpy. The second characteristic is the ionization enthalpy. So at first physical status, we will talk about the physical status also, students. So fluorine and chlorine exist in the gaseous form, and bromine and iodine exist in the solid form. Sorry, not bromine, bromine is liquid. Bromine is in liquid form and iodine is formed in the solid state, iodine and astatine both, but this is the radioactive in nature, radioactive element. So for group 17 members, the characteristic we will only discuss about the fluorine, chlorine, bromine and iodine, because astatine is a radioactive in nature. So this is the physical status of the following members present in group 17. Fluorine and chlorine exist in the nature in the gaseous form, whereas bromine is only a non-metal which exists in the liquid form, whereas iodine and acetylene exist in the solid form. Let's we talk about the second characteristic, that is called the electron gain enthalpy, because non-metals have tendency to accept electron and amount of energy released. So next property is electron gain enthalpy. Electron gain enthalpy. Halogen have very high negative electron gain enthalpy. Halogens have very high value of negative, very high negative value, very high negative value, negative electron gain enthalpy, very high negative value, because they are a maximum electron gain enthalpy. They have very high negative value when we move left to right in a period, because it is smallest in size, so have very strong tendency to accept electron and quickly release energy in the form of negative. So students, when we move in a period, the electron gain enthalpy increases, tendency of electron gain enthalpy increases, and when we move top to bottom in a group, the electron gain enthalpy tendency decreases. So down the group, electron gain enthalpy tendency decreases. Electron gain enthalpy tendency increases, and top to bottom electron gain enthalpy tendency decreases, because halogen is very smallest in size when we move along the periods. So smaller the size, greater the tendency of electron gain enthalpy, so it has high negative value, means it releases lot of energy when it accepts the electrons. And there is a exception cases. See here what is the exceptional cases. So exceptions are there. Exceptions: negative electron gain enthalpy, of chlorine, that is minus 349 kilojoule mole inverse, is more than fluorine. Negative electron gain enthalpy is minus 333 kilojoule mole inverse, while it is expected to be greater, while it is expected to be less, not greater, less. Why? Because fluorine and chlorine, only this is found between the fluorine and chlorine. So student, the smallest size of fluorine and greater electronic repulsion makes the fluorine has less negative value. What is the condition? Fluorine, two condition: smallest size and electronic repulsion, high electronic repulsion. High electronic repulsion makes fluorine has less negative value than the chlorine. In the chlorine, their size is greater than fluorine, and also electronic repulsion is less. So in this way, here is only exceptional case found in the group 17 regarding electron gain enthalpy. Fluorine and chlorine, the high negative electron gain enthalpy of chlorine than the fluorine. Why? Because fluorine has smallest size and electronic repulsion becomes high when the fluorine accepts electron. But in case of chlorine, the size is larger than fluorine and less electronic repulsion. So next we discuss the electronegativity. Next property is the electronegativity. Number 3, electronegativity. Electronegativity. Fluorine has maximum electronegative down the group, move to down, electronegative increases, and fluorine is maximum electronegative in nature. High electronegative in nature is fluorine, down the group electronegative character decreases simply. So in this way we can explain, or we know the most electronegative element in the periodic table is fluorine and second one is oxygen. So now we will discuss the next topic, that is called the fourth topic, that is called the color of the gases present in the salt. So fluorine gives light yellow, and chlorine gives greenish yellow, and iodine, bromine gives reddish brown, and iodine gives violet, deep violet. Whenever test is done in the chemistry lab, the salts of fluorine when treated with acid, the light yellow color indicate the presence of fluorine or fluoride ion in the given salt. Similarly about the chlorine, iodine and bromine. If reddish brown color evolve, that means the salts contain bromide ion. If deep violet color evolve, means salts contain iodide ion. In this way we can detect the presence of halogen or halide ion in a given salts. Next we discuss the bond dissociation enthalpy. As we know, the group 17 member exists in nature in the diatomic forms. So as we know, this existence of this particular member is in the form of fluorine, means fluorine, and like this chlorine, single covalent bond formed between bromine and bromine. Similarly iodine and iodine. So we will talk about the bond dissociation enthalpy. Bond dissociation enthalpy. So what about the bond dissociation enthalpy regarding this member? So their bond length is 143, their bond length is 199, their bond length is 228, their bond length is 266. So bond dissociation enthalpy found that experimentally it is 158.8, 242.6, 192.8 and 151.1. This is bond dissociation enthalpy. So student, the bond dissociation enthalpy of fluorine bond is expected to be more than the bond dissociation enthalpy of chlorine, but it's actually the value is less than the fluorine because high electronic repulsion between the non-bonding electron present around the fluorine atom. So 2, 4 and 6, 2, 4 and 6. So their small size and the electronic repulsion is maximum, make it unstable, so less amount of energy required to break their bond. So here is the trend also changes, because it is found that the bond dissociation enthalpy must be high for the fluorine, because it is expected to be the more. Why? Because small in size and a strong force of attraction, but it is smaller or less value than the chlorine because the non-bonding electrons, presence of non-bonding electron around the fluorine atom, and there will be electronic repulsion takes place. So inter-electronic repulsion, we can say that due to inter-electronic repulsion, the bond dissociation enthalpy is less than chlorine, whereas expected to be more. Next we discuss about the chemical properties like nature of bonding or another characteristic. So let's we discuss about the chemical property. Chemical properties. At first, the nature of bonding. So in this group it form ionic bond as well as covalent bond. Ionic bond with strong electropositive element, it forms ionic bond, and lot of covalent bond also formed with the metals like AlCl3 or with non-metal CCl4 or bismuth chloride, so on. It forms ionic bond as well as covalent bond. So let's we discuss how this is possible for the formation of different types of bonds. So let's we discuss about the nature of bond. Nature of bond. Let's we discuss about the oxidation state. Oxidation state. So student, chlorine show -1, fluorine show -1, and all other elements have vacant orbital, vacant d orbital, so they show -1, +1, +3, +5 and +7, means lot of oxidation state, a wide range of oxidation state shown by the group 17 members. At first we will see the example. Suppose chlorine in ground state, we write the configuration 3s2 and 3p5 and it has vacant d orbital, that is 3d, 1, 2, 3, 4 and 5. So in that condition at ground state it has one unpaired electron, so it show -1 in electropositive element like NaCl or potassium chloride, so on. But it can show +1 also with chlorine, fluoride, chlorides of chlorine. But in the excited state, chlorine in the excited state, we see here the electrons goes into the d orbital and show the +3 oxidation state. So write down the configuration: 3s2 and 3p, 3s2 and 3p and 3d orbitals, 1, 2, 3, 4 and 5, 3d orbital. So 1, 2, 3, 4 and 5. So students, it goes into the d orbital, it also goes on this d orbital. So how many unpaired electron it has? So it has 1, 2, 3 and 4 and 5. So 5 orbitals, unpaired 5 orbitals here. So it show the +3 or +5 oxidation state in the case of ClF5. So it show +5 in the with ClF chlorine pentafluoride, show the +5 oxidation state. Similarly, if only one electron here, this electron goes into so it has 1, 2 or 3 unpaired electron, in this way it show +3 oxidation state. See here how this is happen. So chlorine 3s2, 3p5 and 3d, 1, 2, 3, 4 and 5, 3d. So in excited state, here is 5 electrons. In excited state, suppose this electron goes onto this, so it has 1, 2 and 3 unpaired electron. In that condition it shows +3 oxidation state. Again chlorine 3s and 3p and 3d, 3p. So it is second excited state. So it's so +3 in the first excited state. First excited state is show the +3 oxidation state, and we can draw the formula triprides of chlorine. In the second excited state, this electron goes on this orbital. So now it has 1, 2, 3, 4 and 5 unpaired electron. So in that condition it show the +5 oxidation state. Again chlorine, third excited state. In third excited state, this 3s electron also goes on the vacant d orbital. So see here, 3s, now 3p, now 3d. So 1, 2, 3, 4 and 5. Now third excited state, this electron goes on this vacant d orbital. So it has total 1, 2, 3, 4, 5, 6 and 7 7 unpaired electron. 3s, 3s, 1, 2, 3, 3, 1, 2, 3 and 1, 2, 3 d orbital, 1, 2 and 3 d orbital. So total unpaired electron it has is 1, 2, 3, 4, 5, 6, 7. So it shows 7 oxidation state with HClO4. In this way chlorine show, in this way the family members except fluorine, all the family members of this group show the wide range of oxidation state and form the number of compound. Why not fluorine show the wide range of oxidation state? Because it is more electronegative in nature and it has no d orbital. So fluorine always show only -1 because it is most electronegative in nature, so it does not show the +1 oxidation state because no other element is more electronegative than the fluorine. And other members show the wide range of -1, +1, +3, +5 and +7. Wide range of oxidation states shown by the family members of this group. Next we discuss the another property like. So students, next in the next video we will discuss about the oxidizing nature of the halogen family and the reactivity towards the hydrogen, reactivity towards the halogen means interhalogen compound, their reactivity. So many characteristics we will discuss in the next video. That's enough for today.